All right, so we're going to be doing notes a little different here for a few days, so bear with me as I am trying to get used to the uh, this tool that I'm using to write with, this slate, whatever it's called, little tablet thing. So just bear with me. I'm not really used to using it anymore. So but anyway, as you're going through this video and watching it, I'm just going to move through the problem. So obviously you have the ability to pause, rewind, whatever. So if you need to do that at any point, feel free to just stop and go at your own pace. So when you're doing the notes, I don't know that you're going to have the option of having a paper copy of these notes. So if you are comfortable doing the notes on your Chromebook, a stylus or whatever is helpful for doing that. If you are comfortable doing that, we can worry about getting that stuff printed out later if you do choose to do that option. Or the other thing that you can do is just write it down in your notebook and, just you'll have the paper copy. So you do not need to submit notes to me. You keep your notes for yourself and for the notebook quiz at the end of the quarter. You do not need to submit any of the notes to me, just the homework. So same thing for the homework. If you're comfortable doing it online, you can upload it to Cami or DocHub to do that. Otherwise, do it on a separate sheet of paper, take a picture of it and upload it. The only thing I ask is make sure you double check your picture before you upload it. Make sure that your handwriting is legible. I need to be able to read it. And also make sure that the picture is clear, because if it's blurry and I can't see anything, you won't get credit for that either. So just throwing those things out there. I know everybody was used to doing this stuff last year, but we haven't really been using it much, or if at all, this year. So we want to make sure that we're all on the same page there. So, all right, enough of that. Let's get into these notes here. So first of all, we are going to go back to our systematic graphing stuff. I was trying to do these notes earlier and get this to you today. When I uploaded it into YouTube, I don't know what was going on with the audio. I'm not sure, but there was no audio at all. It was completely silent. So I'm redoing the notes now. I did give you some practice problems on systematic graphing to practice on the 8th. So today is the 9th, and you are just getting some practice on this again. So we're going to start off with the parent function of I'm just going to say y instead of f of x. Y equals square root of x. So if you remember what this function looks like, this is a function that starts at the origin 0, 0 and kind of looks like half of a parabola kind of tipped over on its side. And the point that we tracked here was the point 0, 0. Okay? And again, I'm not going to try to fix any of this stuff, because if I do, it's going to end up looking worse. So just kind of bear with me here as I'm trying to get used to this tablet again. All right, so the first thing that I'm going to do it in this order. I'm going to do the 2, and then the minus 3, and then the minus 4. Okay, so that's going to be my first step, second step, and finally my third step, which will be actually my fourth graph, because first graph is the parent function. So here we go. First up, we have the 2. So the 2, remember, anytime you have this number out front here, this means that we are going to multiply the y values by that number. So I'm starting at the point 0, 0, which we take 0 times 2. We still get 0, so that's not going to change anything. But if we look along this graph, somewhere over here we have the point 4, 2. Okay, so like let's say right here we would have the point 4, 2. And basically what we're going to do is take this y value that would be 2 and multiply that by the number out front, which is 2. So that is what makes the graph taller. So we want to just make sure we're showing that this graph is taller than the previous graph. All right, so we'll label our graph. This is y equals 2 times the square root of x. Our point has not changed. It is still the point 0, 0. Up next, I'm going to do the minus 3. So let's think back to when we did this. What does that minus 3 do to our graph? Well, it's with the x, so it will move in the x direction. So this will move left or right. And it's the opposite of what we think. So a minus 3 means I'm going to move this 1, 2, 3 units to the right. So here is my new point, and it will have that same general look to it. So what I did here was 2 square root of x minus 3. All right, my new point, instead of 0, 0, is now at 3, 0. Okay, so I moved it over 3, and it's now at 3, 0. And the last step here is the -4. And to graph, the other thing I'm going to mention, this Smart Notebook watermark that's down here, it's always there in that same spot. Like it says there, if I plug it into a smartboard, it would go away, but I do not have that option, even in my classroom, because I don't have a smartboard in my classroom. So it's just going to be there. We'll just ignore it. So the -4 is going to take this whole graph and do exactly what it looks like, and it's going to drop the whole thing down 1, 2, 3, 4 units. So I'm still over 3. I'm just down 4 now. So this is the new look of my graph. Let's write our equation. Y equals 2, square root x minus 3, and a -4 on the outside. So my new point now is still over 3, but now it is down 4. So 3, -4 is the new point. The last thing that we're going to do here is we're going to label our domain and range for this final graph only, not for each of the individual graphs, but just our final graph. So remember, domain is your x values. These are all the input values. So all the x values that this graph will cover, they start at 3 and go to the right. So starting at 3, going to the right means infinity. 3 will get a bracket because we can use 3, right? 3 minus 3 is 0. That's okay. We're allowed to have 0 in a square root. We just can't have 0 in the denominator, which we don't have a denominator. So 3 is okay. And remember, infinity always gets a parenthesis. For the range, we're looking at the y values that this is covering. And it starts down here at -4, and then it goes up forever. So -4 to infinity. Again, infinity always gets a parenthesis. And in this case, -4 will get a bracket. So that's your final graph right here and your domain and range for that function. All right, so now let's get into the new functions here. So looking at our sine function, okay, and this is the parent function. This is the function we will start with, and we'll move it around exactly the same way that we did every other function that we've done so far. Whether it was an x squared or square root, cube root, x cubed, the exponential functions like e to the x or ln x, we've done a lot of functions moving them around. So that process is the same. It hasn't changed. What does change here for sine and cosine is we're tracking more points. So instead of just tracking 0, 0 or 1, 0 or 0, 1 or any of those things, we actually have 5 points that we're tracking. Okay, so we're building up. We started with 1 point, and now we're building up to multiple points that we're tracking. Okay, but it is no different. It's the exact same process. We're just doing it a couple of times. So if you have your unit circle, go ahead and get that out. Pause the video. Get your unit circle out. Have that in front of you so you can see what I'm talking about when we get to these quadrantal angles. All right, so excuse me. When we look at these values, there are multiple values in between 0 and pi over 2. Okay, so this is 0 degrees and 90 degrees. The 3 specific ones we looked at were 30, 45, and 60. But there's also a bunch of different angles. There's a 10-degree angle. There's a, an 86-degree angle. There's a 52-degree angle. Like, there's all those angles are in there. We just mainly focused on 30, 45, and 60-degree angles. But we're getting a little bit more specific when we're doing the graphs, and we're just going to look at the quadrantal angles. The main reason why is because these give us nice numbers to work with, okay? Like, for example, if we try to do sine of pi over 3, we know that that's square root of 3 over 2, but where are we going to graph that? Like, that's a decimal, so, getting into decimals, it's a little iffy, like, where should we put it? But using these, we get nice numbers to work with, okay? Now, if you have your unit circle in front of you, if you look at that, excuse me, sine of 0, since sine is your y-coordinate there, sine of 0 gives you 0, okay? Before we do any more of this, actually, I want to back up a step here. If you look up here, on your unit circle, you had x and y points. But when we're graphing this function, your x and y, your input and output, your domain and range, they're different because the input, your domain, is all of the angle measures in radians. So the input, your domain, is the angle measures in radians. And then the y value, or your range, is all of the y coordinates from the unit circle. Okay, so your x coordinates are not the x coordinates from those points, but instead they are the radian angle measures of the unit circle. So input is radian angle measures, output is the y coordinates from your unit circle. For sine, cosine it's different, but for sine. All right, so if we look at our unit circle again at pi over 2, sine is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And then sine of 2 pi, because 0 and 2 pi are the same number, they're just coterminal, they should give us the same y coordinate. And we'll use that when we graph them over here as well. Now, you can see that these are nice numbers to plot. 0, 1, and negative 1. Those are nice numbers to plot. So we're going to start out here. This is your 0 degrees, and the y-coordinate there is 0. Okay, next, pi over 2 is 1. Sine of pi over 2 is 1. I'm going to use these marks as, I'm going to say 3 marks as 1. So I'm going to put a little line up here and say that this right here is 1. Just to kind of spread the graph out a little bit. And I'm going to go 1, 2, 3. This right here is negative 1. Okay? I'm not going to put it right at the first block because then it's all going to kind of be squished in there. This way it'll help spread it out and give us a good, accurate view of what this looks like. Okay, so pi over 2 gave us 1. We have that. Next up is pi. Pi gives us 0. So at pi, we're right here at 0. 3 pi over 2, I'm going to slide this up here so I can get away from that watermark a little bit. 3 pi over 2 is negative 1, so we're right there at negative 1. And then remember, 2 pi has to be the same as 0, so that's back at 0. So we had the point 0, 0, and the point 2 pi 0. We're back where we started from. Okay? Now, the one mistake that I see happen a lot here is when people connect these, do not do this. When people connect these, they go straight line, straight line, straight line. And that is not at all what this graph looks like, okay? These are a nice, smooth curve. It's called a wave. So it's, you know, the sine wave is going to look, I'm going to try and do this so it will look a little better. The sine wave is going to look like that. Pretend it went through that point there. So it will have a nice, smooth curve to it. Okay, and like I mentioned yesterday, because we looked at this on a unit circle, I had mentioned that, like, you know, this is a cyclical function. It goes in a cycle. Every 2 pi, it repeats itself. So over and over and over again, this is the same thing. It can continue to the right and just go up and down forever to the right, and the same thing to the left, up and down forever. And if you have your graphing calculator, you could type that function in, y equals sine x. Set your x min to 0 and your x max to 2 pi. Set your y min to negative 1 and your y max to 1. And you'll see a graph that looks exactly like this. Okay? But understand that this is not the whole function. All right? So let me switch over and I'll show you what this function looks like. All right, so here is what the sine function looks like. And you can see if we scroll, if we scroll out, we can see that it's just repeating over and over again. If we go to the left or the right, it's the same thing over and over and over. It just keeps repeating itself, okay? Now, for what we are looking at, we are just looking at this section here. So we started at 0, if you could follow my cursor here. We started at 0 right here. We went up to this value, and if you click on this, by the way, if you haven't used Desmos, Desmos is a great graphing utility. So we could see we had the point 0, 0. We followed that up to this point here at pi over 2, 1. We came back down over here as pi, which is a little bit bigger than 3, so pi 0. And down here, this point was 3 pi over 2, negative 1. And then back to where we ended at 2 pi 0. All right, so I just want to point out to you that this graph does continue on forever. There's 5 pi over 2, and there would be a 3 pi and a that's 5 pi over 2 there. So 7 pi over 2 and 4 pi. Like, it just keeps repeating over and over and over again. So we're just going to cut it off. We're going to do one rotation around the unit circle, which is also referred to as one period of this function. All right. So that's all we're looking at is we're just starting here at 0, 0. We go up, we go down, and we go back to 2 pi 0. All right. So you can see here that's what we have graphed in this domain that we have cut off the rest of the function, okay? And this is what we're going to do. This is the parent function we'll work with, and we'll move it around just like we did all the other systematic graphing stuff, all right? So before we get into our first example, though, let's talk about some of these properties. So this right here, this funny word, this is sinusoidal. So the properties of sinusoidal graphs, this is the general term to represent sine and cosine functions, okay? So they're called sinusoidal. And here is the standard equation. We will be adding to this, but this is where we're starting for now, okay? So we have these two numbers that we're going to look at, okay? We have A and B. And we're going to use these when we find amplitude and period. So let's get into this. Amplitude is the absolute value of A. Okay, so if we have negative numbers, that's not really incorporated into the amplitude. It does flip the function, but the amplitude is the absolute value of A. And on the graph, the amplitude is half of the height. Okay, so the overall height of the graph, let me come back here. The overall height in this one went from 1 to -1. So that's 2 units, right? It's 1 unit down, 1 more unit down. So that's 2 units. So the amplitude is actually half of that. So the amplitude is 1, okay? Which if we look at our parent function is f of theta equals sine theta. So the number out front here is a 1, okay? So that's why half of the height is 1. The overall height is 2, so half of that is 1. That's what your amplitude is, okay? The next term is period, and I'm going to leave the graph here to show you what the period is. The period is how long does this take to repeat itself. So it starts here at 0, and it goes up and down and back up, and it takes 2 pi units for it to repeat itself. Okay, so that is the period of the function. 2 pi divided by the absolute value of b. Okay, 2 pi is the parent function period. And then in order for us to get the period of the function that's moved around, we're just going to divide that by b, which is the number out front of the variable. Okay, this is what we're going to do in the next set of notes, so we're not doing this today. And on the graph, like I said, the period is the length that it takes for 1 full cycle of the wave. So basically, how long does it take to repeat itself? The last term is probably a term that you've heard before, and that is frequency. You may have heard this term when referring to sound waves or radio waves. You know, like when you turn your radio onto like 91.3 or 94.1 or 103.7, those are all frequencies that the radio station sends out their sound waves over those frequencies, and then your radio picks that up by tuning your dial into that frequency. So these are all related to each other. Sound waves and the sine and cosine graphs are ways of representing sound waves. Okay, so we'll get into all of this stuff throughout the chapter, but I just wanted to mention that now because frequency, you might be thinking, I heard that term before, but I don't know exactly what it is. So that's what that is. And if we look at this fraction here, it's just the reciprocal of the period. Okay, so frequency is the reciprocal of the period. On the graph, what this is saying is in 1 unit interval, how many times does the graph complete a cycle? Okay, so in a 1 unit interval, it's basically just saying, did it complete 5 times, 2.5 times, 3 times, whatever. That's what the frequency is graphically. So what we're going to focus on today is just the amplitude. All right, so let's get into these examples here. So first example, f of theta equals 2 sine theta. Please understand that this is no different than if I were to write f of x is equal to 2 sine x, okay? I'm just using this variable because theta is representing our angle measure that we're plugging in. That is the domain for the trig function. So this is what we're going to start with. All right, so we're only doing this on the parent function from 0 to 2 pi. So that's all we will graph is just that period that I showed you in the last parent function, 0 to 2 pi. So we're starting at 0. We're going to say pi over 2 is our first one. And this is what it will always look like. This is what you're always starting with, okay? So don't think that I'm like just throwing out some random numbers here. These are the x coordinates that we are always starting with. They're going to change, all right, as we get into period and phase shift. These values will change, but these are the parent function values that we start with. We're going to go from 1 to -1, again, not just because I want to, but because that's what the function does. All right, so let's look at our parent function again. We had the point 0, 0. We went up to pi over 2, comma 1. Then we had the point at pi 0. 3 pi over 2, -1. My points are going to run into my fractions there because that's the best I can do with this thing. All right, so here, again, here is your parent function that we are starting with. All right, so there's your parent function. F of x equals 2 sine, oops. Where's my eraser? There we go. No 2. Sorry, we did not do the 2 yet. Let's get back into it here. Just sine x. There we go. All right, now do our 2. This is what we're going to do here now. Our first and only graph, we're just going to do the 2. So what does the 2 do to our graph? Let's draw a coordinate plane again. All right, I'm going to extend this over here a little bit, even though we're not using it. Now, that number out front means we're going to take these y coordinates and multiply by that number. So this number right here means we multiply, so multiply by, well, let's just say multiply y values. Multiply y values. Okay, so we're going to multiply the y values by whatever number is here, regardless of the number. It could be a 2, it could be a -4 like in the next problem, it could be a 1/2, it could be a 10, whatever. Multiply it. So let's look at our first ones. Well, this is at 1. The parent function is at 1. If I multiply by 2, now I'm up here at 2. This one down here at -1, if I multiply that by 2, well, now I'm down here at -2. My x coordinates did not change, so this is still pi over 2 pi, 3 pi over 2, and 2 pi. Okay, so those are the x coordinates. They are not changing today. Later on in the next set of notes, they will change, but for now, they're not changing. So first up, let's look at the y coordinates. My y coordinate here is 0. 0 times 2 is still 0. That didn't change. Next, pi over 2. Well, my pi over 2 value was at 1. 1 times 2 is 2. So that's up here at 2. Pi is at 0. So 0 times 2 is, yep, still 0. 3 pi over 2 was at -1. Okay, 3 pi over 2 is at -1 down here. Multiply that by 2. Now it's down here at -2. And 2 pi should be where we started from. But if we look at this, 2 pi was at 0 times 2, and we are still at 0. So connect the dots. We go up and through our points. Keep going down. Oh, no. I don't know what happened there. I don't like that. Let me fix that. I'll get used to this thing, but for today it's just like it's new all over again. So there we go. That's good enough. So here is our new function, f of x equals 2 sine x. Okay. One thing that we're going to label here, we're not going to label domain and range just yet, but we do want to label what we changed. So what we did now was the period. And the period for this function is the absolute value of 2, which is just 2. Okay? So that's the period for this function. All right, last one here that we're going to do together. First of all, we're going to start off with our parent function again. Okay, so we just had it on the last page. We're going to do it again. This way we're used to this. We don't have to memorize it because we'll have done it so many times that we'll know what it is. Hopefully, that's the idea at least. So here's your parent function again. That's a 3 pi over 2. You can't really see it, but that's 3 pi over 2. And again, same thing that we started with over there. This is your parent function. All right, so here we go. And we'll label this f of x equals sine x. All right, so the -4, again, it's out front. It's being multiplied. So what that means is I'm going to take my y coordinates and multiply by -4. So this will do two things. First of all, it will stretch it out because it's going to go 4 down to -4. But the other thing it will do is flip it. So let me put my x coordinates in here and I'll show you what I mean. My kid's playing basketball outside and throwing the ball against the house, if you're wondering what that loud noise was. All right, so let's follow our points here. So the first point is at 0, 0. Multiply that by -4. Where is it at? Still 0. The next point here was at 1. Okay, so the y coordinate here is 1. 1 times -4 is -4. So you can see the flip there. It's now going down instead of up. The next point was at pi 0. So again, still at 0 because 0 times 4 is 0. 0 times -4 is 0. Next point right here is at the y coordinate is -1. -1 times -4 is now a +4. And the last point, 2 pi was at 0 times -4, it's still 0. So we're going to go down, hit that point, go up through that one, hit that point, and back down. Write our function, f of x equals -4 sine x, and we will label the period. So the period here, absolute value of -4, which is just 4. Okay, so again, we're going to keep adding to this each day, few steps, just one at a time. So if you are unsure about this step, please make sure that you're asking questions before we move on to the next step. I will put a practice worksheet for homework into the homework section. So fill in your notes. The notes are for you. Homework, make sure you're doing that either on Kami or DocHub if you're doing it digitally. If you're doing it in your notebook or on a separate sheet of paper, like I said, make sure that your writing is legible. Make sure that your picture is clear when you upload and submit that to Google Classroom. Okay, make sure that you submit your assignment by the beginning of class. If you're in first period, the beginning of your class is going to be different than fourth period. So just make sure that it's submitted at the beginning of class so you can get credit for it. And if you have any questions, let me know. Feel free to rewind, watch it as many times as you need to. But if you have questions, either send me an email or write a private comment on Classroom and just let me know. But like I said, we're adding on to this every day. So if there's something you're unsure of now, make sure that you're asking before we move on.